friends, and welcome to this episode of the AI Show. This week I am in Lisbon, Portugal, so reach out if you want to say hello. I am at the Azure Dev Summit in Lisbon, Portugal. I'm pretty excited about that. I'm going to be talking all about agentic AI, so how about them apples? I'm excited to be here. I'm so glad that you're spending some time with us. So I thought we'd jump right in. All right, let me tell you what we're doing today. So here we go. We have this this handy dandy writing thing. So for the first half of the hour, we're going to be talking about the voice. Wow, that was kind of fun. The voice live API with Deb. Now this thing is really cool. Over the last year or so, since Ignite of the year before, I've been actually using the real-time GPT-4.1 real-time API to do really cool demos, and I love them. And the cool thing about this is Deb's gonna come on and show us like the expanded version of all of his stuff, so that I can actually do more. So you're gonna love what she has to say, and hopefully I can start to incorporate that, and you'll see that in some later shows. And then part two, oh, oops, wrong side. Part two, we're gonna look at the new GPT-5 model, but then do a little contrast with 4.1 and 03, so we can get a sense for like, why are these things different and how we can use them. And this is gonna be with Alex. So those are the two things that we're doing today. Now, here's the thing. I'm pretty excited because we have coming up in about, I think it's 6-ish weeks. It's like the week of the 16th of November. We're going to be going to San Francisco for Microsoft Ignite. So let's take a look at some of this stuff. I have a browser here. Let's see if I can figure out, tell you, Microsoft Ignite 2025. Let's see if there's some stuff out there. And you're probably thinking like, what the heck is Seth looking at? There you go. It's right here. Okay, right here. Here's all the. Oh, look at that. Ignite the possibilities. Ignite the possibility. I mean, that's. Here, let me turn my sounds on. Turn this on. Ignite the possibilities. I need to turn that up. Ignite the possibilities. Yeah, I mean, that's what we're doing. Igniting the possibilities. This is November 18th. I said 16th. 18th to the 21st. My wife's birthday is on the 21st, so I'm going to leave the day before. I'm going to be honest with y'all. Let's see if they have any sessions in there. Session catalog. I have not. This is like the first time I'm checking this. So let's see here. Let's see if I'm in here. I probably am. Here we are. Agentic identity and other enterprise superpowers. Oh, that's not me. AI defense. So there's some other Seth people. How cool is this? Cool. So this is the only session that I think I'm in. I might be in more. I don't know. I'm not gonna lie. Sometimes I don't know what's gonna happen. Oh, this is cool. So agentic identity and other enterprise superpowers. So that is what I'm doing at Ignite. There's a bunch of other stuff. I'm working on some new demos. Hopefully they'll show up in some sessions. And I want to do voice again. So that's why I'm excited for Deb's voice live thing. So that's that. So this is session catalog. Make sure you tune in. I think I'm also going to be helping with hosting the live show at Ignite. That's in 6 weeks. So let's look at the Azure Dev. There we go. Azure Dev Summit in Lisbon. This is what's happening this week. So we have some really cool people in there, and then I'm there too. So let me find myself here. Let me find myself. Am I the only Seth? Oh no, have I been canceled? Let's scroll down here. Maybe they're just pictures. John, Neil. Oh, I'm not on here. Maybe. Oh, there I am. They did not cancel me. So I have a talk. Here's the talk. Practical guide to agentic AI. AI powered agent conversation, blah, 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 learn why. And that's the first thing. And then the second thing is this one. Oh man, see, here's the thing. What happened was the world changed from when I wrote this to when this is happening this week. And so I'm actually working on looking at the Microsoft Agent Framework, which is brand new. And so I'm like learning that one real fast, and then we're gonna have a full day of learning how to do that. So agentic ops, we'll go to the insights on creating a robust agentic ops plan, real world examples, and hands-on practice. Yes. Here's a secret on this one, by the way. Anytime you see star ops in front of anything, it's literally just DevOps, but with other stuff. So yeah, that's what we're doing. That's what we're doing with that. So this is this week, and I'm still working on this one because the stuff is just literally brand spanking new. So that's the Azure Dev Summit in Lisbon, Portugal. All right. So without further ado, let's go to the Voice Live API with Deb. Take it away. You're not going to want to miss this episode of the AI Show. We talk all about Azure AI Voice Live API with my friend Deb. Make sure you tune in. Hello, welcome to this episode of the AI Show. We're talking all about the Azure AI Voice Live API with my friend Deb. How you doing, my friend?
I'm good. How are you?
Fantastic. So tell us who you are and what you do.
Yeah, so my name's Deb Adeogba, and I'm the lead for speech services for applied engineering under the AI platform.
Well, it looks like your dog is not interested at all in anything we have to say. You know what? Their loss. I'm just saying, because there's a lot of cool stuff when it comes to building voice agents. Primarily, like, it's hard, right?
Totally, yeah. I mean, there's a lot of challenges when it comes to building voice agents. There's things that you have to really think about, like, you could see, accuracy is probably the top one that you're really thinking about. You want to have high accuracy on your input and your transcripts, and especially if you have like domain-specific vocabulary. Naturalness, you want to make sure it's a natural conversation between your application and the user. And then, as a company, you want to have customized audio outputs because you want to make sure that you maintain that brand image and you have like a personality consistency. The other thing now with the introduction of large language models, you want to have a choice of your generative AI model. And that includes, both large language models and also small language models. And then, you want to make sure that there's robustness in terms of, interruptions and end of turn detection in different scenarios, especially in noisy environments. And then, you may want to embody your agent as well. You may want to have a visual identity, and that can really help improve engagement. But really, it comes down to, three things that you want to keep on the lower end, which is, engineering costs, time to market, and also latency.
All right, so this is awesome. So tell us about how the Voice Live API helps us with all of these things.
Yeah, so we took all of that stuff into account, and so what we did is we created a unified, real-time speech-to-speech interface. So what it does is it takes speech-to-text, LLM, and also text-to-speech, along with some conversational enhancements, and also avatar, if you'd like. And it puts it into a single, low latency pipeline that you can use out of the box, where you get, your own choice of Gen AI model. You can use our unparalleled Azure speech recognition and synthesis. And then also, you can use customizable voices and also customizable avatars as well.
This is cool. And I'll put our faces up for a second. We did a demo at Build last time that used the GPT-4.1 real-time API. And it was a hoot to do it, but I could sense that it felt like there was more stuff that needed to be added to make it more robust. Tell us about the more stuff.
Right, yeah. And actually, GPT Real-Time is available in this service, so you can use GPT Real-Time with Voice Live API as well.
Cool.
But yeah, it's like full of features. So, the first thing that's really important is that, you can use the voices that are included in, for example, some of the real-time models, but you could also use our Azure speech. So we have over 140 locales for speech to text, 600 plus pre-built voices, over 150 locales, and we actually just released Neural HD V2 voices. So those voices are actually contextually aware. So, for example, if I write a sentence that says "I'm very sad today," a lot of text-to-speech services will read it out as "I'm very sad today." But what our service does is it'll read it out with emotion. So it'll say "I'm very sad today." So that's a big game changer. And then you have, choice of your generative AI models, like I mentioned, GPT Real-Time. We also have GPT-5, 4.1, a bunch. We have our own Phi series as well that you can use. And we also have Bring Your Own Foundry model, which is now in preview. Customization is a big thing that you can utilize with VoiceLive API. So you can do custom speech, custom voice, custom avatar, and we also just introduced a 4K support for custom avatar as well. And then another big thing is it integrates seamlessly with our Foundry agents. So that also helps if you're already building a Foundry agent, you can add voice to it very easily. In addition, we have conversational enhancements. So when you're piecing this type of a voice agent together, a lot of times you have to add like a third party on to handle stuff like echo cancellation or noise suppression or interruption detection. But we've actually included all of that in here for you. We've already architectured it for you. And then I mentioned the avatars as well. So we have a whole library of avatars, but you can also do custom avatar as well. Because nowadays, a lot of people want to use a visual embodiment, right? To have a more personalized experience with their users. And then if you're doing call center, we made it easy to build call center voice agents with telephony. And you can do that through Azure Communication Service. And there's more to come on that as well. And then, for developers, we have rich development resources. So we support C#, Python, and that's on top of WebSocket protocol. And we have additional languages coming soon as well.
And this is near to my heart because like the last year's worth of demos, I've been doing it all with voice, starting at Ignite, of last year, where we did a telephony version of this. And like, I'm excited to get my hands pruny to see all of the news, because I've been using sort of older APIs and older models, but now I have a whole plethora of choices. And I understand you brought something to show us what that looks like. Can we go to that now?
Yeah,
Let's do it.
Today, we're going to build a shopping assistant agent that recommends popular Microsoft products based on customer needs. But first, we'll need to create an agent in the Azure AI Foundry Agents Playground, and then we'll enable audio input and output with VoiceLive API. So first, let's navigate to the Agents Playground. And then we'll click on Microsoft Device Shopping Agents. So you can see that we chose GPT-4.0 for this, but you can choose any model you'd like, even Phi. Another thing to point out is that for the knowledge section, we've prepared a catalog of popular Microsoft products. We've uploaded the file as agentic knowledge for RAG purposes. So at this stage, we have a fully functional shopping assistant agent, and it's well-versed in Microsoft products. However, it's just text only. So now let's use the voice enable your agents to give this agent a voice. So let's go to Voice Live Playground. In Voice Live Playground, there's also some configurations that you can actually change to meet your needs. So you can see on the right here, you can choose your generative AI model. So we have Bring My Foundry Agent as the model that we chose. We also have several different ways to change or utilize some of the features with speech input. So we have auto detect language, we have VAD, end of utterance. We also have audio enhancements such as noise suppression and echo cancellation. And we have a phrase list as well. So you can actually put words in that are domain specific or jargon that goes with your industry that you want the speech to text to recognize. For speech output, we have a ton of library voices, neural HD voices that you can use, but you can also use custom neural voice as well. And for if you want to add an embodiment to this agent, you can also use avatars. So we have a bunch of avatars in our library, but you can also do a custom avatar as well. So for this demonstration, we're going to use an avatar. So we'll use this avatar and we'll hit apply. Okay, so let's test this out.
Hello, how may I help you today?
Hello, I'd like to buy a laptop for my brother who's in high school. Can you recommend a Microsoft device that's super high performance? I don't have any budget constraints.
For your brother who's in high school and needs a high-performance laptop, I recommend the Surface Laptop Studio 2. Here's why it might be a great fit. Surface Laptop Studio 2. 1. High performance. It features
Okay,
the
thank you for
13th
the
gen Intel
recommendation.
Core
I
i7
actually
processor.
want to buy, I want to ask another question. Sorry to interrupt you, but I want to buy a gaming device for my nephew, but I have a very small budget. Can you recommend a device for me?
No problem at all. For a budget-friendly gaming device, I recommend the Xbox Series S. Here's why it would be perfect for your nephew.
Okay, I think
Xbox
I've
Series
got what
S.
I need. Thanks so much for the recommendation. So as you can see from the demo, it just takes a few minutes to create a shopping assistant agent, enable RAG for it, and add voice input and output capabilities through the VoiceLive API. So just a quick summary of the VoiceLive API features we've walked through for large language models. It allows full flexibility on model selection, including any of the large language models that we support. On the speech to text side, VoiceLive API has automatic language detection, noise suppression, and echo cancellation capabilities. And it also supports phrase lists to customize speech-to-text behavior to domain-specific vocabulary. On the TTS and avatar aspects, VoiceLive API supports a wide variety of pre-built voices and avatar, and we also support custom voices and custom avatars. So conversations powered by the VoiceLive API feel natural and authentic with elegant handling of interruptions. And these all make the Azure VoiceLive API the go-to solution to add voice input and output to any agents.
This is cool. I was looking at that. It's kind of cool that that's all in there, because like when I did this stuff, I had like an API backend and I needed to write sockets, and it was a lot of stuff. So what does this actually look like in the code? I know you brought a slide for that. Let's take a look at that.
Yeah, so you saw in the demo, like to add voice to agents, it's pretty simple, right? If you're trying to, if you've already built the agent or you're trying to build a Foundry agent, it's really simple to just add, the agent connection string, the agent ID, and the authentication token. You can see that on the left. So it's just literally 3 lines of code.
I see. And so when you're actually here, let me put my face up here. So when you're actually like, you build an agent and you just want that agent to have voice, you literally just add those 3 things, and now you can interact with it over the WebSocket, and it uses whatever intelligence that agent has, correct?
Exactly.
But you could still use the previous one if you're building a more custom multi-turn more thing as well.
Right.
Is that right? You can still use the okay, cool. So what are we looking at on this, right? What is this telling us?
Yeah, so one of the things that's really a cool feature is that you have so many choices for voices, right? So you can use the built-in voices from the Gen AI model that you've chosen, but you can also use Azure's standard voices as well, and that's where we have the 600 standard voices across 150 locales. But also you can use custom voice. So, if I wanted to create the voice of Seth, I could actually add that in as well, and it's very simple. It's very simple to add it,
And how does one go about it doing that? Is it just like you give some utterances and some text with it, and that's what it does?
Yeah, for custom neural voice, basically, we require 300 to 2,000 sentences. So you would record 300 to 2,000 sentences, and we have a self-serve portal, and you would upload your voice data to the self-serve portal, and it takes about 20 to 30 hours to get a voice back.
I'll be honest with you. I actually have done this before. I actually went through and recorded with this microphone, and it's a very good one.
Nice.
And the thing was speaking, and this was like years ago, and so I know this is technology is fairly mature. It's very good.
You should do another one, because now we have HD voices. So the HD customer voices are contextually aware, so it would actually match your tone and your emotion as well.
Oh, maybe. And you're saying like what, 3,000 sentences? So it's like an afternoon of like reading stuff and put
300 to 2,000 sentences, or 30 minutes, basically, about 30 minutes. Yeah. So it's not bad.
Now here's a question. I know we're kind of going off the rails here, but like, is it like something in the portal that like says read this thing and then you read it and then you hit next, or is it like, how does it work?
Yeah, so for custom neural voice, and we also call it professional voice. Basically, we in GitHub we actually have sentences that you can read. So we offer sentences for you to read. But like, let's say you own like Seth's Bagels or something like that.
Yeah.
So maybe you need like domain specific words to your bagel shop. So what we usually recommend is that if you have domain specific words, you should write some of your own scripts as well and put those words into like sentences and how you would say them.
That's amazing. And then it's just, I'm guessing it's just a bunch of WAV files and it's some huge data set and you upload it and it's like, go do your work. And then it does that.
Put it in the oven and then wait for it to cook. Yeah.
I love it. All right. So the other thing and the last thing that I wanted to ask you about was this notion of the avatar. Tell us about that.
Yeah, so avatars or visual embodiments are becoming more and more popular nowadays. So a lot of people are, really opting in to add this visual embodiment to their agents or to their voice agents. So we actually offer standard avatars that are in our library. So we have quite a few of those you can choose from, and then those will use our standard voices. But you can also create a custom avatar as well. So it's kind of the same. It's kind of along the same vein as custom neural voice. You would actually record video, right, of yourself, and you would upload it to a self-serve portal, and you get an avatar back that looks like you and exactly. And then you can also create a custom neural voice with that, so you can not only have just your custom avatar, but also your voice that also matches it. So you can see as usual on the right side of the screen, it's very easy to invoke that avatar as well.
Well, I'm excited because I'm writing the next set of demos for Ignite and for Beyond, for AI tours, and I'm going to use all of this stuff. So Deb, I might be bugging you every once in a while, if that's okay. This is amazing. Where can people go to find out more?
Yeah, so you can go to AKA no, hold it.
Voice Live. I put it down below so people can see it. Because you know what? I knew we were going to. I'm trying to be helpful here.
You go to aka.ms/voice-live-GA.
Fantastic. And that's just a blog post that talks about the Voice Live GA. And is this generally available now?
It is. It was generally available October 1st.
Like I said, I'm rewriting the entire voice pipeline of my thing, and I'm going totally to do that. And then obviously, if you want to play with it, you go to Foundry Playground for Voice Live as well, right?
Yes, exactly.
And then what is this link here? Voice Live Docs. What does this do?
Yeah, so if you want to go check out like how to use the API and the SDK, this is where you go. This has all the developer documentation.
Amazing. Well, thank you so much for spending some time with us, my friend.
Thank you so much.
And thank you so much for watching and learning all about upgrade your voice agent with Azure AI Voice Live API with my friend Deb. Thank you so much for watching, and hopefully we'll see you next time. Take care. All right, how about them apples? We should give her a round of applause. That was awesome. Thank you so much, Deb, on that. Yeah, I'm excited to use the Voice Live API. There's a lot of new stuff that just wasn't there. One of the things that I'm thinking about doing is recording some of my voice so that the Voice API talks like me. But would that be I don't know. What do you think? Is that like Uncanny Valley stuff? What do you think? Is that Uncanny Valley? The other thing is, what do you think about the avatar? Should I make an avatar of myself? Or is that too Uncanny Valley? Put it in the comments. I'm interested in what you have to think about that. All right, so that's Voice Live API with Deb. Now let's talk about GPT-5 with Alex Hughes. Take it away. You're not going to miss this episode of the AI Show. We talk all about AI evolution explained. GPT-5 versus 4.1 versus 0.3, smarter choices for smarter business. My friend Alex, make sure you tune in. Hello, and welcome to this episode of the AI Show. We're talking all about GPT-5 versus GPT-4.1 versus O3. How do you make the right choices with my friend Alex? How you doing, bud?
Hey, Seth. Great to be here. I'm doing pretty good. How are you doing?
Fantastic. So tell us who you are and what you do.
Awesome. Yeah. So my name's Alex. I'm a product manager on the Azure AI Foundry models team. And so what I do is I help bring the newest, latest, and greatest models from our amazing set of model providers, companies like OpenAI, xAI, Meta, and we bring those to Foundry so that our customers can use them in their agents and building their applications.
So this is all awesome, but I feel like once you have a lot of choices, it's hard to make a decision. So I'm hoping you can sort of help us out with that. How do you know when to use what? Can you give us a little primer?
Absolutely. So choosing the right model is a big challenge. So there's so many different models. We're bringing new models, and our providers are creating new models all the time and releasing them. So picking the right model, you really have to understand what your use case is, and then have a clear understanding of what the model's trade-offs are. So what their pros are, what their trade-offs might be. So which models are more expensive than others, what models are more performant in different categories like reasoning than others, and that'll help you pick the right one. And I'm happy to help with that with GPT-5 and some of the other models we have.
All right, let's start with GPT-5. How do you explain this one?
Yeah, so GPT-5 is the latest sort of model family from OpenAI. So when we say GPT-5, we're not just referring to a single model, we're referring to a family of models. And in this case, GPT-5 contains both reasoning models like GPT-5, GPT-5 Mini, and Nano, and then also a chat model. So picking GPT-5 for your use case really depends on what specifically you're looking to do. But since we're bringing reasoning and conversation into one family, you can really do anything with GPT-5, anything you can think of within your organization. What GPT-5 really excels at is code generation. And then you also have a ton of flexibility with things like tool calling. And I'm going to talk more about that today. So that's really what GPT-5 is great at.
So it's more of like a collection of models. GPT-5 is a sort of a family of models, which is something that I didn't realize beforehand. Is that a good assessment?
Yeah, exactly, Seth. So it's a family of models, a collection of 4 models to be specific.
All right, so let's go to the next slide. Tell us about each one of those.
Yeah, so we have 3 reasoning models. And as we've seen with other models in the that have been released by OpenAI, they sort of use this naming convention of mini and nano for smaller and faster models that are also reasoning models. So we've sort of shifted over from the O-star framework to, in this case, just GPT-5. So we have GPT-5, which is the mainline reasoning model. It's going to be best suited for those highly complex queries that require deeper sort of chain of thought reasoning. It's really good for things like analytics and complex decision making. GPT-5 Mini is a little bit smaller than GPT-5, lower latency, but still great for reasoning. And then Nano is the smallest, fastest reasoning model. And then, of course, we have Chat, which is best optimized for things like multi-turn chat scenarios.
So here's a question, because we had Jennifer Marsman talk about GPT-5, but maybe I didn't understand it correctly. Is the GPT-5 like the one all the way at the top? Does that one like decide to do like model routing to different models, or am I mistaken here?
Yeah, so great question, Seth. So GPT-5 is this collection of models. Within the OpenAI API directly, they use a routing service that essentially will pick the best model based on the query. We also have on Azure AI Foundry, we have a model router, and our model router is really great at helping you pick the best model based on the input. It does it seamlessly, it does it for you. So you input your query, your prompt, and then the model router will route it to the best model based on the prompt.
Awesome. All right, so let's take a look at this here, because there's a lot of stuff to think about when we start to compare these models, correct? So it's good to get the framework of the 4 models, well, family of models, 4 things. But can you explain those, like the difference here? Because there's a lot to think about.
Yeah, so GPT-5 is the latest set of models from latest set of reasoning models from OpenAI. So we've had other models in the past that have excelled in different categories. We know that O3 was really good at like math heavy tasks, for example, but O3 is being phased out now. in favor of GPT-5, since GPT-5, in terms of the performance benchmarks, as you can see, does perform better in those categories. So we're seeing GPT-5, in particular, the mainline reasoning model, is outperforming O3 in those areas where O3 was the strongest. We also see with GPT-5, we have a larger context window. We have 400,000 input tokens compared to O3 with 200,000 input tokens. So GPT-5 not only supports more input tokens, it's also going to perform better across those benchmarks. We do see that its output cost is slightly more expensive, only by $2 for the output, but the input is considerably less expensive there too. So GPT-5 is really the kind of evolution of O3. I just want to kind of emphasize that point. We're kind of, from a reasoning model standpoint, GPT-5 is the next evolution there. And then compared to 4.1, GPT-5 chat is sort of what the next step there would be. But I want to emphasize that GPT-4.1 still excels in some certain categories, in particular categories that require a large input context. So large document analysis, things like that.
I see. So O3 is, but you can still use that one, but that one's it's gonna be deprecated in favor of 5 because 5 does the things that O3 does, but better. But then if you have a need for a larger context window, are concerned with cost, but it's not really off that by that much, you would go with GPT-4.1. Is that what I'm understanding?
Exactly. Yeah. So GPT-5 chat does a really good job at handling those low latency real-time chat scenarios that 4.1 is also really good at. But 4.1 does have a bigger context window.
Got
So
it.
if you need a ton of context, 4.1 is great for that.
Yeah, and to me that's kind of a different task, right? Because it feels like that would be more of like a process automation where you're looking at very large things.
Yeah.
Someone's not going to chat 1 million tokens in the context window, is my guess. But that's I don't know. Maybe there is someone who can do that.
No, you're right. It's probably an unlikely thing. Yeah.
All right. So let's take a look at the next slide here. Let's tell us about what makes GPT-5 a little bit different.
Exactly. Yeah. So we took a little look at the benchmarks there and some of the improvements, but in terms of functionality, GPT-5 supports some new things that are pretty cool. So the first is free form tool calling. So in the past with tool calling, we would need to specify those tools using structured JSON. With GPT-5, you can basically just send the raw text payloads. So if you have some Python code, if you have a SQL query, you can just send that directly to the tool, and the tool will be able to handle that with GPT-5 without actually needing to sort of structurally define that tool with JSON. And this is really, really great for making your applications more developer-centric. Getting started with tools is a lot more seamless. GPT-5 also supports parallel tool calling. So this allows it to call multiple tools essentially in parallel in a single model turn. So it makes using the model faster, and in turn, it makes your agents run faster. So a user doesn't have to wait for one tool call to happen, then another, then another. If they're not dependent on each other, then they can all just happen at the same time. So this makes your agents run a lot faster.
So help me understand this from a mechanical perspective, how it works. So effectively, you put something in the chat. If you get the raw response, it'll tell you to call 3 function calls, for example. And then you can run those at the same time and then put them back on the response back on the thread at the same time. Is that what that means?
Yes, essentially, yeah. So what we're doing is we define our functions within our application, and I'm going to show you how to do this in just a minute here. So
Cool.
You define your functions, what your tools, what you want them to do, maybe calling some sort of weather API or some time or whatever the tool might do. And within your application, maybe you're prompting your model to do something. And if the model determines it has to use multiple tools to accomplish what you're asking it to do, what it's going to do is call those tools in parallel. So it's going to use different threads to call them at the same time, and then it's going to get those responses back and then integrate them before it returns the final response to the user.
I see. So that's a function of the actual GPT-5 service that's doing that on your actual behalf. Because I mean, most people, maybe they don't know this, but the LLM itself doesn't call functions. It's a service that calls the functions. It's the LLM that recommends the functions to call. The service just makes it much easier to call multiple of them at the same time. Am I getting this right?
Yeah, that's exactly right.
All right. So let's take a look at some of the parameters. So effectively, to make this actually work, you gotta set parallel tool calls to true. One of the things
Mhm.
that I did not get the understanding of the trade-off or the difference. What's the difference between reasoning effort and verbosity? Because help me understand the difference.
Yeah. So reasoning effort, there's 4 values for it. And there's one new value for GPT-5 called minimal, which is the lowest possible level of reasoning. And then we have low, medium, and high, which are the same values for previous models. Essentially, what this reasoning effort parameter controls is how deeply the model is going to think before calling various tools or answering the prompt from the user. So if you want the model to think a lot, you can set reasoning effort to high. This is going to make latency longer because the model is going to take more time to think, and it's going to allow it to create sort of more deeper analysis, think deeper before doing those various actions. If you set it to minimal, it's going to think in the lowest possible amount while still being a reasoning model and still sort of doing that chain of thought thinking. Verbosity, on the other hand, isn't actually controlling how deeply the model is thinking. It's simply adjusting the level of detail the model is providing in its response. So if the model is more verbose, it's going to give more detail with its responses, and if it's less verbose, it's going to give less detail with its responses.
This is really handy because I've had models kind of like say a lot of stuff, and it's like, whoa, I wish I could control that, and this is a control of that sort of thing.
Exactly. Yeah.
All right.
So
So
you can have a model that's super, super thoughtful, but maybe you don't want it to kind of give you paragraph long responses. So
I love it. And so here's the diagram that I should have pulled up when we were asking about function calls. What are we looking at here?
yeah, so here we've got just a sort of an example diagram of what parallel function calls essentially what it essentially is. So before parallel function calling, we would do sequential tool calls. So up at the top, we can see on the various model turns, we're calling some various function, in this case, read file, with 3 various files, and then we're getting those responses. With parallel tool calls, it's just one model turn, and then we're actually doing all 3 of those reads at the same time, and then getting that response. So it's all happening at the same time instead of 3 separate model turns. And what this enables is essentially just faster agents, faster thinking, and then a better sort of interaction with users.
So this is awesome. Is there any way to show us what this looks like in code?
Yeah, absolutely. So what you see here, Seth, is 2 files that I've created, 2 Python scripts. And what I'm going to be showing you here is some regular function calling, which I'm sure you're very familiar with. And then I'm also going to show you parallel function calling. So how can we parallelize these function calls when we have multiple function calls to make? So first, with regular function calling, here what I've done is initialize my Azure OpenAI Service Client, define my deployment, and what I've got is some time zone data. So we have some various cities around the world, Tokyo, San Francisco, Paris, and I have the associated time zone for those cities. And then I've defined a function here called getCurrentTime. And this function takes in a location, a city, and it's going to return the current time at that location. So I'm using a function of datetime here to do that. So that's what this function here is doing. And then what I'm doing here is I'm defining that tool to use with my model. So I'm actually using GPT-5 Nano in this case. And GPT-5 Nano, as Seth and I talked about, is like a great model for low latency scenarios. So Seth, it's really good for building applications that need some reasoning, but need to do it really fast. Nano's really good at that.
That's cool.
Yeah. So I've defined the tool here. In this case, I'm defining the getCurrentTime tool. So I'm describing it as sort of getting the current time in a given location. I've defined the properties, and then what's required here, which is just the location. So what I'm essentially prompting the GPT-5 Nano model here with is, what's the current time in San Francisco? So I'm asking GPT-5 to call the tool and then give me the current time in San Francisco. So down here, I'm sort of defining what the API call looks like, processing the model response, and then here's where I'm actually handling that particular function call. So pretty standard use case for a tool. And if I run this function, I run this file, we can see that we're going to get a response with what the current time is in San Francisco. So we see that it's 11:56 a.m. in San Francisco right now.
Yeah, and could you scroll up, because I want people to see this. This part is the part that's like kind of the magical bit. Here, when you get the response on line 83, if it's asking for a tool call, you look for the name and then you execute the actual function with the arguments, and then you append the response of the actual function call to the thread. Is that right?
That's exactly right. Yes.
Perfect. And then you get a good response. Okay, cool. That was really fast too.
Yeah, exactly. So GPT-5 Nano is super quick, super low latency, but it can still do really strong reasoning. So it's not as strong in terms of its reasoning capabilities as the mainline GPT-5 or GPT-5 Mini, but it's still very strong. So it's really good at those scenarios where you need something that's quick, but also thoughtful.
Got it. All right, so let's take a look at GPT-5 parallel tool calling to see the difference.
Yeah. So let's dive into this one here a little bit. So we're setting things up the same way using the same model, GPT-5 Nano. But in this case, we've got a little bit more data to work with. So instead of just time zone data, which we still have here, we've got some new data for the weather in these various cities as well. So we have the temperature and then the unit of temperature in these cities.
Got it.
So I've got the same function here. Right here, get current time. This is doing exactly the same thing that I was doing here in function calling. But I've got this new function as well called get current weather. And this one's going to take in the location and the unit. Oh, let's not do that. And then it's actually going to return the current weather in that location. So we have the data. And then here's a function that can basically check what the weather's like in that location. So I'm going to run I'm going to define the tools the same way I did before. Get current time is defined the same way. And then here, get current weather is defined as well. I'm requiring the location as input. And then sort of what this function is doing is it's getting the current weather in that location.
Mm-hmm.
And then I am prompting the model with what's the weather and current time in San Francisco, in Tokyo, and in Paris. And one thing I'd love to just call out here as well is here I'm defining tools using JSON. With GPT-5, you don't have to do this. So you can just call the function directly with Python or with SQL, for example.
What does that look like?
Yeah, so essentially, if you have a like a Python script that does something, or let's say you have an SQL query. You have an SQL query that calls like a database, and it's getting, let's say in this case, it's getting like employee data, for example. So what you could do is with that SQL query, you could just have it defined in plain text. So it's just a raw text like string, SQL query
as
string.
part of the prompt.
Exactly, as part of the prompt.
Makes sense.
Yeah, and then you have that string defined. You know what it's going to do, and then you basically can have the model use that string and call a tool directly with it. So you don't actually need to, in those cases, define the tool with structured JSON. You can just have the raw text SQL query payload, and you can just send that as the prompt to the model, and then the various tools will get called with that raw text payload.
I love it. All right, let's take a look at how we parallel call these things.
Yes, absolutely. So if we scroll down a bit here, we've defined those tools. Here's our first API call. Here we're asking the model to use the functions. And then here's where we're actually processing those responses. So as you can see, Seth, it's really the same handling as we saw before with function calling. So in the response, we're essentially just going through and seeing, is the tool in the set of tools that we have? And then if so, we call it, and then we append those results to the message that the model is going to return to the user.
Got it. And now is this, so here's it. I see. So in the for loop, in this, it might be returning more than one of these function calls, and you're just executing them and put them on the thread as they come in.
That's right.
Okay, cool.
Yeah.
Cool. All right, let's see what it looks like when we run it.
Yeah, so let's go ahead and run this one here. Yeah, so first we see really fast response there. And then what we're seeing is all of the function calls that were made. So we have this all printed out here. So we can see get current weather is called with San Francisco. And then we see get current time is called for San Francisco. And then we see that it happens for Tokyo, the 2 functions, and then it happens with Paris with the 2 functions. So essentially, GPT-5 is calling all of those tools for all 3 of the cities, and it's doing this in parallel. So it's not just calling one, then another, then another. It's actually doing it all at the same time. And then it's printing those results, and we can see we have, we're printing those results, and we can see for the 3 cities, we have the weather and the time for all 3.
Well, this is awesome. Where can people go to find out more about this? I have a couple of links. Tell us about this one.
Yeah, so
the blog post. Tell us about the blog post. Sorry, you're probably not seeing it. I'm pointing at something you're not looking at. So this is a blog post. Tell us what's there.
Yeah, so highly recommend you check out this blog. We highlight what's new with GPT-5, its advantages, the new features we're enabling on Foundry with it. So highly recommend you check that out.
Awesome. And then on Learn, there's some information similar to what you just showed. Is that correct?
Yeah, we show all of our OpenAI models, the reasoning models, what you can do with them, and then, of course, examples of how you can use them.
Well, this has been amazing. Thank you so much for your time, Alex.
Thanks so much, Seth. I appreciate it.
And thank you so much for watching me learn all about AI Evolution Explained, GPT-5 versus 4.1 versus 03. Smarter choices for smarter business, my friend Alex. Thank you so much for watching, and hopefully we'll see you next time. Take care. Awesome. Thank you so much, Alex. Let's give you a round of applause here also for you. Another air horn for you. Thank you so much. That was super informative. It was cool that he spent so much time answering my questions. So yeah, that's pretty exciting. Thank you so much for that, Alex Hughes, for that. Next time on the AI show, let me see if I can pull this up here, because I always forget. And because I never know. You know how like you're like working on stuff and you're like, what's the next thing? Let me go in here. Hold on one second. I'm finding it. The next episode of the AI show, I think we have hold on. It's okay. It's saying it okay, here we go. The next episode of the AI show. Okay. Azure AI Translator with Krishna, and this is an awesome one. It's all about machine translation, something that we absolutely need. That's the first half of the show. And the second half of the show says TBD. So I'm going to just show you stuff that I've been working on. So make sure you join us next week, October 20th, for the AI show. Hey, thanks so much for spending some time with us. I know your time is valuable, and we appreciate every second that you spend it here with us on the AI show. Thank you so much for watching, my friends, and hopefully we'll see you next time on this, the AI show live. Take care.